My name is Nadia and I'm pleased to present my topic today on algal biotechnology in aquaculture, sustainable feed and bioremediation solutions. In recent years, the use of algae, both microalgae like Spirulina platensis and macroalgae such as Urva lactuca, has gained a lot of attention in the aquaculture industry. These organisms are not only sustainable but also multifunctional. They help us address key challenges in aquaculture such as feed costs, fish health, water pollution, and environmental sustainability. Through this presentation, I'll be sharing current findings on how algal biotechnology can improve aquaculture practices. I will also cover how algae are used as functional feed additives, as probiotic partners, and as bioremediation agents to clean up aquaculture waste. We will also explore integrated systems like IMTA that bring all of these ideas together. Let's begin by looking at how microalgae are being used as functional feed ingredients in fish farming. So, microalgae such as Spirulina platensis play a powerful role as functional feed in aquaculture. One of the key benefits is improved digestive performance. According to Shai et al. 2024, improved histological intestinal features were observed in the midgut of tilapia fed with spirulina-enriched diets. This signifies enhanced nutrient absorption and gut health. Spirulina also exhibits strong antibacterial activity. Studies by Qureshi and Ali and Vo et al. Found that it enhances bacterial clearance of pathogens like E. coli and S. aureus due to its immune potentiating properties. Additionally, spirulina contributes to detoxification. It can chelate toxic heavy metals like arsenic and cadmium, reducing their harmful effects. This detoxifying ability was demonstrated by Han et al. And further supported by Jung et al. Overall, spirulina is not only a high-quality nutritional feed, but also an agent that supports gut function, immunity, and detoxification in aquaculture species. So we go to the next one. Spirulina improves tilapia health. In addition to supporting digestion, Spirulina platensis enhances the overall health of cultured tilapia. Abdel Latif et al. And Wu et al. Showed that spirulina significantly improved antioxidant capacity, blood health, and also immune response. This led to lower antibiotic use and reduced stress levels in high-density culture system. Spirulina is also biochemically rich. It contains gamma-linolenic acid, C-phycocyanin, essential vitamins, and also carotenoids, all of which strengthen the fish antioxidative defenses. Studies by Zhang et al. And Wan et al. Confirm that these compounds contribute to improve resilience and reduce oxidative damage. This means spirulina is not just fat, it's a bioactive supplement that enhances tilapia health from the inside out. Okay, so now let's focus on one of the more specific effects of spirulina. It is impact on fat levels and body composition in fish. According to Zhang et al., diets containing spirulina significantly reduce both the hepatosomatic and viscerosomatic indices in tilapia. These indices reflect the proportion of fat stored around the liver and internal organs, so a reduction indicates healthier, leaner fish with less unwanted fat. Along with that, lipid deposition and blood cholesterol levels were also notably lower, making the fish more marketable from both a health and quality standpoint. Spirulina also boosted the activity of key digestive enzymes like lipase, amylase, and protease. These enzymes are essential for breaking down fats, carbohydrates, and proteins, which improves digestion, nutrient absorption, and overall feed efficiency. This dual action, better digestion and less fat accumulation, makes spirulina a highly effective feed additive for improving both fish health and commercial value. So when we combine spirulina with probiotics, especially bacillus strains, we get even better results. Lee et al. And Promya and Sheikh Manat found that this combination significantly enhances the gut microbiome of tilapia. It raises intestinal enzyme activity and also improves microbial diversity, which strengthens digestion and nutrient uptake. On the immune side, Khalid et al. Reported increased lysosome level, higher phagocytic activity and greater expression of immune cytokines. This marker shows stronger non-specific immune responses, meaning that the fish are better able to fight off pathogens without the use of antibiotics. So using both spirulina and probiotics together creates a more resilient fish population with improved growth, digestion, and also disease resistance. It's a cost-effective way to enhance fish health naturally. So next, let's look at how macroalgae like Ulva lactuca are used as bioremediators in aquaculture. Algal et al. Showed that Ulva could remove 55% of nitrate and 31% of phosphate from aquaculture wastewater when applied with 75% biofloc inoculum. This is very significant as nitrate and phosphate accumulation is a major pollution concern. Despite absorbing these nutrients, Ulva retain a high protein content over 22% and strong chlorophyll levels, meaning it can also be reused as a valuable feed source. Additionally, research by Hellstrom et al. Revealed that Ulva maintains optimal growth under variable salinity and nutrient conditions. This means it performs well even in less stable or fluctuating environments, such as during seasonal runoff. This characteristic make Ulva lactuca a powerful tool for both nutrient recycling and also sustainable feed supplementation. So beyond general bioremediation, Ulva lactuca also plays a major role in treating shrimp aquaculture wastewater specifically. A study published in PeerJ in 2018 demonstrated that Ulva could remove up to 80% of nitrogen and 64% of phosphorus from shrimp pond effluent. Impressively, shrimp bred in this treated water grew just as well as those raised in fresh, clean water. So there is showing no compromise in performance. On top of that, supplementing shrimp diets with just 3% Ulva meal significantly improve growth rates and feed conversion ratios. The shrimp also had increased lipid and carotenoid levels by 30 to 60%, which improves immune function and product quality, especially appearance. So, in shrimp aquaculture, Ulva serve both as a water purifier and a functional feed enhancer, creating a closed-loop benefits for the system. In polluted environments, Ulva lactuca also helps by absorbing toxic metals. Karim et al. Found that Ulva could effectively sequester metals such as iron and manganese, reducing their availability in the water. This means less metal toxicity and better water quality for aquaculture species. Furthermore, Ulva acts as a natural biomonitor. According to Farias et al., the related species, Ulva australis, has been used to monitor zinc pollution in marine environment. This shows that Ulva not only cleans the system, but can also serve as a living indicator of environmental health, something especially important in regulatory and conservation efforts. In summary, Ulva offers dual benefits in managing heavy metal stress and helping us track pollution trends in aquaculture. Okay, so now let's look at nutrient control in recirculating aquaculture system or RAS, which rely heavily on water reuse. Hernandez et al. Showed that cultivating spirulina inside RAS tanks significantly improved the removal of nitrogen and phosphorus from wastewater. This helps in reducing the need for frequent water exchange and increases sustainability. Even more importantly, this system showed fewer ammonia spikes as algae absorb waste nutrient, toxic ammonia levels drop, leading to lower stress and a reduced risk of disease in fish. This demonstrates that spirulina is not only a feeding ingredient but also a tool for water treatment in high-tech aquaculture systems like RAS, improving efficiency and reducing environmental impacts. So finally, let's discuss one of the most promising sustainable aquaculture system, which is integrated multi-trophic aquaculture, or known as IMTA. As described by Chopin and Bushman 2008, IMTA integrates different species such as fish, shellfish, and seaweed into one system. Waste products from one species become nutrients for another, creating a balanced, self-sustaining environment. This not only reduces pollution and improves productivity, but also diversifies income streams for farmers, since multiple species are produced at once. Al-Hafid et al. Emphasized that IMTA systems are also more resilient to environmental changes like salinity or nutrient fluctuations, making them more adaptable to real-world challenges. IMTA is a prime example of how we can move towards circular aquaculture practices that support both productivity and ecosystem health. So next is the benefits and challenges of algal biotechnology in aquaculture. So starting with the benefits, first and foremost, algal products like spirulina and ova help reduce feed costs. This is because they can partially or fully replace fish meal or synthetic supplements, which are often expensive. Next, algae improve water quality by absorbing excess nutrients like nitrogen and phosphorus, especially in RAS systems and shrimp ponds. This help minimize pollution and promotes a healthy aquatic environment. Another major advantage is the multi-product year. Algae not only serve as feed, but can also be used in nutraceuticals, fertilizer, and even biofuels, adding more economic value to the aquaculture system. Lastly, algae contribute significantly to environmental impact mitigation by recycling waste, reducing greenhouse gas emissions, and supporting integrated farming systems like IMTA. However, there are several challenges that need to be addressed. One is the high production cost, especially for large-scale spirulina or microalgae cultivation, which requires controlled condition, harvesting equipment, and energy input. Contamination risks also pose a problem. Algae can easily be affected by bacteria or pollutants in open system, which reduces quality and safety. Another issue is strain selection. Not all algae species are equally efficient, so finding strain with the right growth rate, nutrient profile, and resilience is essential. Lastly, scalability is still a barrier. While algal biotechnology works well in lab or pilot setting, scaling it up for commercial aquaculture operations remain complex and costly. In summary, algal biotechnology offers sustainable and multifunctional solutions to improve aquaculture, but overcoming technical and economic barriers will be key to maximizing its full potential in the industry. That's all from me. Thank you.